In this lecture, we will be discussing a concept called price elasticity, and we'll take a look at how it can help us understand future concepts in this course. The syllabus includes various elasticities of demand and the price elasticity of supply. Let's start by examining the concept of price elasticity of demand. Price elasticity of demand is essentially a unit-free way to measure the responsiveness of the quantity demanded of any good to a change in its price, assuming that everything else remains constant. I'll explain why the unit-free part of the definition is so important a little later on. We calculate price elasticity of demand by dividing the percent change in a quantity of a good by the percent change in price of that good. I would like to note that in introductory microeconomics, we need to observe a change in the price and/or quantity demanded to be able to calculate the price elasticity of demand. To calculate the percentage change in quantity demanded, we're going to subtract the old quantity from the new quantity, or Q2 minus Q1. We're going to divide that by the average of the two quantities. This may be a bit confusing, and to be honest, I don't find it super intuitive either, but this is the way it's taught, so do what you will with that. We'll perform a similar calculation for the change in price, P2 minus P1 over the average price. We then divide the answer we got in the first part by the answer we got in the second part, and we can get an answer for the price elasticity of demand. I would like to note, however, that for all of the situations that you will encounter in your introductory microeconomics course, the price elasticity of demand will be negative. Normally, we just drop the negative sign and take the absolute value of the price elasticity of demand to perform any analysis. At this point, you might be asking yourself a couple of questions. Hopefully this slide can clear some of them up. So we just learned that in order to calculate price elasticity of demand, we use average prices and average quantities. We do this because it gives us the price elasticity of demand at the midpoint between the two prices and quantities. It's just for accuracy purposes. We use percentage changes to calculate the price elasticity of demand because we want to get rid of all the units, and the easiest way to do that is to divide a percentage by another percentage. We want to get rid of units in elasticity because this way we can compare elasticities between different goods. Imagine trying to compare a change in the quantity of coconuts to a change in the quantity of iPhones. It really doesn't give you a whole lot of information. By getting rid of units, we're able to extract a bit more data out of our numbers. The value we get for the elasticity of demand is almost always negative. It makes sense because we know that price and quantity are inversely related. Basically, if we decrease price, we expect an increase in quantity and vice versa. Therefore, one of the percentages in our calculation will always be negative, thus rendering the elasticity value negative. If we end up with an absolute value of elasticity of demand that is less than 1, we say that demand is inelastic. If we think back to the way we calculated it, it means that a change in price brings about a proportionally smaller change in the quantity demanded. Think about goods such as insulin, which are necessary for certain people to survive. A change in price would not bring about that much of a change in the quantity demanded because it is a necessity. A good's elasticity of demand can also change based on the way we categorize it. If we try to look at the elasticity of demand of food, then it would be extremely inelastic. However, if we go into a subcategory of food and look at a specific type of food, such as apples, then we would see an increase in the elasticity of demand. This is because apples have more substitutes than the broad category of food. There is a special case where the elasticity of demand might equal 0. In other words, the quantity demanded of a good does not respond to changes in price at all. Consider a good such as oil. If the price drastically changes on one day, then in the short run, the quantity demanded of oil wouldn't change. We don't have any alternative means of transportation or production of goods and services readily available. Therefore, in the short run, the elasticity of demand of oil might even be perfectly inelastic. Unit elastic demand just means that a change in the price induces a proportionate change in the quantity demanded. If the percent change in price equals the percent change in quantity demanded, then the elasticity of demand would equal 1. If the price elasticity of demand is greater than 1, the good is said to be elastic. In other words, the good's quantity demanded is very responsive to change in prices. This is often something we see with goods that are not necessities. Going back to the subject of categorization, if we talk about very specific goods, then the elasticity of demand tends to be a lot more elastic. For example, if we talk about red apples from a particular brand, the elasticity of demand would be much more elastic than if we were to talk about fruits in general. Just like with the case of perfectly inelastic demand, there is an extreme on the other end of the spectrum as well. If the elasticity of demand turns out to be infinite, then we say that the good is perfectly elastic. Essentially, a small change in price brings about an infinite change in the quantity demanded of the good. I briefly touched on a few factors that can affect elasticity of demand, but I will go over them formally one more time. If a good has a lot of close substitutes, then its elasticity of demand will be much higher. It will be an elastic good. On the other hand, if it does not have many close substitutes, it will be an inelastic good. Another factor is the proportion of income spent on the good. If a high proportion of income is spent on that good, then it will be a fairly elastic good. If a low proportion of income is spent on a good, then it will be a fairly inelastic good. Lastly, the time elapsed since the price change is another important factor. This has to do with the time that the market has to find substitutes for the good. Back to our oil example, if the price of oil rises, then in the short run we don't really have any feasible alternatives to turn to. However, if the price of oil continues to rise year over year, people might switch over to electric cars. Therefore, in the long run, the quantity demanded of oil would fall, but in the short run, it would not. An important distinction that needs to be made is the fact that the price elasticity of demand of a good is not the same thing as the slope of its demand curve. It really depends on which part of the good's demand curve we are examining, because elasticity changes over different quantities and prices. On a linear demand curve, the midpoint on the demand curve will be where the elasticity of demand is equal to 1, or the good is unit elastic. On the top half of the curve, the good is considered to be elastic, and on the bottom half of the curve, the good is considered to be inelastic. The concept of elasticity can be helpful to firms who might be considering pricing strategies. If they know that the elasticity of demand for the good is elastic, then they can infer that a change in price would bring about a greater change in the quantity demanded. Thus, if they reduce price, their revenues would increase. However, if they increase the price, then their revenues would decrease. Similarly, if a firm knows that the elasticity of demand for the good that it is selling is inelastic, then it won't earn any more revenues by decreasing the price of the good, since a decrease in price brings about a proportionally less increase in the quantity demanded. Thus, it could increase the price of the good in order to increase revenues. Maximum revenues occur at the point where the elasticity of demand of the good is equal to 1, or where the good is unit elastic.